When we come to our number 10, it was coming from partial fractions. It was saying express f of x into partial fractions and hence find the integral of f of x, of which now, if you want to see partial fractions, the detailed part of it, you go to the playlist and you scroll down until when you find partial fractions. But what we have here, the question is there at the start of the video, it says f of x equals to that. Now, you see, first of all, it's improper. It's improper because the highest power in the denominator is 3, yet the highest power in the denominator is 2, meaning it's improper. So what we have to do is first long divide, the easiest method. Now what we do, you have to expand this times this to get this, then this times this to get this, then you long divide by doing this. In long divide, now you put this inside. Then this one follows. So this, now, you start, this was negative, so it's the highest power which is dividing. So this goes here, minus 3x. It's always the highest power that is dividing. So this goes here, minus 3x. Then this times this to get now. And then this times this to get now, minus 3x squared. Then we subtract there. Now after, when we subtract now, is that we are going to be having this and this going away. So this and this to get us a 5, 2 minus minus to get 5x squared. Now we bring these ones down. Then we say this goes here, minus 5. So this times this, 5x squared. Then this times this to get minus 5x. Then we subtract. This will give us 0. Then minus to give us 2x plus 1. When we stop dividing when the power of the divisor is greater than the power of the remainder layer. So meaning, if I'm to write my f of x, I'm going to be having my f of x as this. Then plus the remainder over the divisor. Now, sorry, it's better to write it that way. So we have x into 1 minus x. As simple as that. Now, we now consider this and we take these to partial fractions. Now we say, consider. Now this one is what we want to partialize. Now it's going to be equivalent to, now you see, this one is linear and this one is linear, so we have a constant over x plus a constant over 1 minus x for it to be proper. Or else the power in the numerator should be less than the power in the denominator for it to be proper. So if you get LCM, so we are going to be having a into 1 minus x, b into x equals to now 2x plus 1, because when you multiply this and this, you will be able to answer the denominator. So there we can say when x is 0, I put here 0 and I put here 0. You can see that now my a is going to be 1. Then I say when x is 1, in simple terms, I'm equating this to 0. I'm going to be having my b equals to 3. Therefore, I have the a, I have also the b like that. So meaning, the whole of this is now going to be 2x plus 1. 2, now my a, 1 over x, 1 minus x. So meaning, now I can write my f of x. Now, my f of x is going to be now, remember this, minus 3x, minus 5 now plus. Now where there is this, I'm going to substitute this, which is 1 over x plus 3 over 1 minus x. So after doing that now, we come to the next part. They are telling us that, hence integrate this. So to integrate that, I'm just going now to say the integral of the function of that f of x with respect to x. Now I'm going to be having also the integral now of the whole thing there minus 3x minus 5 plus now 1 over x plus 3 over 1 minus x dx, which I can ably separate for you to be able to see well. Minus 3x minus 5 dx plus dx. So if you want to see how to integrate these ones, you can tap the playlist, then you scroll down and you see integration there. You will see all these integrals there. So this is going to give us minus 3x squared over 2 minus 5x plus natural log of x minus 3 natural log of 1 minus x, of course, plus a constant of integration. So that's what we have in that case. So that is now our integral for f of x dx. So that's how we had to do number 10. It was very easy, almost 3 marks like that. Okay, let's move to number next.